Hello all, welcome to a new video. In this video, we will be discussing about Spark serialization. This is part of the ongoing series on 5 S's of Spark. We already have two videos, one on Shuffle and one on Spill. This is on serialization issues that we see in Spark. So let's get started. Basically, what uh, is a serialization in terms of normal computer science is that converting any object to a byte stream and then from byte stream converting it back to the object notation is called serialization and deserialization. And this is done to transfer or to move an object from one system to another system over the wire. And this is what Spark also does. Uh, the reason Spark does that is because Spark has to transfer many things in its distributed environment, and those things require serialization and deserialization. So what are the places where Spark needs this serialization and deserialization is something like this. We have data transfer. So Spark has concept of shuffle. In shuffle, what happens? Data from one executor is sent to another executor for for the purposes of being combined or for the purposes of being aggregated as a task. So that data transfer incurs serialization and deserialization because that transfer happens over the wire. And while doing that, for example, let's say if we are doing a group by operation and we have key and value of that. So each of that Java object will have a overhead of around 16 to 32 bytes because of the serialization and deserialization that happens. So 16 to 32 bytes doesn't seem much for a smaller data set, but when we have billions of rows that we are trying to process in Spark, this small overhead also translates to a very big number. It can go into GB or TB even. So this is a very uh, challenging thing that we have to deal with in Spark, and we try to minimize this serialization overheads. The best way to do is to minimize the data transfer itself. But we can't do up to a certain limit. Only we can reduce the data transfer. Then comes the serialization and deserialization packages, which are efficient enough to do those work for us. Then when Spark tries to send a task, for example, let's say if we have written that we want to do certain operation on the data frames that we have. So how Spark sends that information to all the executors is that it serializes that task definition and then sends it to each of the executor that okay, this is executor already has a data. So it says this is your data, take this function and run this function or run this task on that particular data set. That's where that task needs to be serialized and deserialized because it is going over the wire. Then we have UDF functions. Again, this is something, sorry, yeah, UDF function, which is something has to be serialized and deserialized. Then we have caching. So before the data gets stored into the memory, or in case if it is being spilled to disk, in case of persist, or in that case also the data is first serialized and then deserialized while reading. Shuffling, as we mentioned, this data transfer is part of that. So again, the data is serialized in there, serialized and deserialized while doing the shuffle. Checkpointing is also where the data gets serialized and written to the disk. So these are various places where we see how data is or objects of the program are getting serialized and deserialized again and again. And this causes this uh, this demands for us to be able to implement a serializer which is good at doing this at a faster rate. These days, information about how much data is getting serialized, deserialized, is recorded in the Spark history server or the live web UI. Not all, but partially. Some of them are recorded directly. Some of them can be calculated indirectly. Uh, for example, executor deserialized time and result serialization time is defined directly. Serialization, deserialization in the event timeline is also defined explicitly. Other places we will have to do what you call we will have to do inference that okay how much time it might have taken in the serialization deserialization process. There are certain rules. Let's say if we are trying to write a new class in our Spark code. So because of this serialization needs, there are certain rules that has to be followed in while we are writing the code. The rules are that functions needs to be serialized. Objects which are referring that function itself that has to be serializable. If that object had certain attributes and we are taking only that attribute, still the whole object has to be serialized. If we are using UDFs, that UDF should be able, we should be able to serialize that UDF. On Spark does it as a closure, so that also needs to be serializable. And if that objects are not serializable, like whatever we are trying to do, if so we have to create a class which extends the sorry, we will get an error. And to fix that, we will have to create a class which extends this serializable. There is a serializable class which we have to extend so that and implement all those interfaces, abstract methods, so that we can make this class work with Spark. And there are errors. So when we have this exception which says the task is not serializable, then we have to remove the object which is not getting serialized, or the object graph which is not getting serialized. If an object cannot be serialized by Java serializer, we can either remove that item, or we can try to let's say we are accessing something which is shared across executors, then we can leverage broadcast rather than using this. We have to make that value as lazy, or we can also make that transient. Then other way of is that the reference object that we have, we can make a singleton object to that. Then or we can move the object which is getting which is not able to serialize into a generator or iterator. That also helps in case we are using Python objects or Python programming. So in let's say we created an UDF in Python. So in Python it uses pickle serializers to send the functions which is again has slowness issues. We can use arrow which is in memory columnar representation, and it's a what you call it's a for it's engine or compute agnostic format which is understood by multiple systems. So that helps us to reduce the overhead of serialization and deserialization. Plus, if serialization happens also because it is columnar, so it can serialize the whole object, whole column in one go rather than being row wise. So that helps as well. By default, Spark has two serialization libraries available in Spark distribution itself. One is Java serializer, and another one is the Cryo one. But if we want, we can have custom ones. Like for example, Fori is another open source project which is very good at serialization and deserialization. It is being used in Flink. As of now, there are no publicly stated companies which are using Fori with Spark, but there is a discussion going on in Spark community as well that to support Fori uh, as a full engine itself as a native engine that ships out. So that will have to be checked whether it is not there, but we can implement ourselves as well. We can combine the uh, we can include the Fori implementation in our code bases and then we'll try out. Not all objects might be serializable as of now, so we have to test it. So it is not something which is production tested, but there should not be an issue. Mostly it should be compatible. Spark also tries to do certain internal optimizations to remove the overhead of serialization. For example, the tungsten binary format of the unsafe row is it avoids per row serialization and its usage of heap memory with compact pointer based layout. So that removes certain overhead of serialization. We also can use columnar shuffle in case we are using any native engines. For example, Databricks has Photon. There is a open source project called Gluten with a Velox engine, and Data Fusion Comet is also there. So those native engines avoid per row serialization, and instead they do the columnar batch mode of serialization. So that reduces the what you called the serialization and deserialization overheads. So that can be another approach. Uh, as we mentioned, if we have classes which are not serializable, then we can extend it. And also there is one other approach is to avoid using the objects directly. Then, same as broadcast, we can also use accumulators to reference objects throughout. Accumulators are in something which can be used for updating multiple values from different executors. So, broadcast is from driver to every executor for sharing the same data. Accumulator is something which is kept in driver and every executor can update it. So if we want to have a shared common state across executors, instead of creating custom objects, we can use accumulators. Uh, then the Spark transformations that are there, uh, that also means instead of writing our own custom Python functions or Scala or Java definitions, we can use Spark's transformation, which uh, uh, which will actually help us to the transformations which are happening are serializable or not serializable, because those transformations are native ones are already serializable. But if we are writing something of our own, we have to assess and test it what transformation we are doing. Also, if we don't do a large collect, that also will help because collects requires the data to be transformed from the executors to the driver and it goes over the network. So if we don't do that, if we have to just check, we can do a take first, select top five. That we can do. That will have very minimal overhead, but doing a collect and full collect will something require a lot of overhead. Uh, the other approach is that instead of creating our own custom objects all the time, if possible, if we can define the schema for the data sets that we are creating beforehand and use that schema to create the data frames and use that schema to create the data sets or data frame, that those are more memory efficient because those encoders being used by uh, Spark engine to do the schema enforcement are serializable, and they use cryo serialization in that case as well. Similar to that, broadcast we can use for read-only data. So using these approaches, we can handle serialization overheads that comes with Spark. So this was it for the video. See you in the next video. Thank you.